Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have discussed about that is how we can give the IUPAC nomenclature to the alcohols, as well as we have also discussed about the common name. And now what we are going to do is we are going to do the structure of the alcohol. So now let's understand that and let's get started. So friends, in this topic we are going to discuss about that how we can write the structure of the alcohols, and in this case basically we are provided the IUPAC nomenclature, and let us understand that how we can draw the structure for that one. So starting with the first one, that is what we have is we have 1-ethyl cyclohexanol. So how we can write the name for this one? So it is very simple process. That is, the name is cyclohexanol. Obviously we should understand that is it consists of a cyclohexane, and since it is cyclohexanol, obviously it will have an OH group that has been directly attached to this carbon atom, and that's the reason now this is cyclohexanol. But the position here is 1. That means, as well as we have also discussed in the IUPAC nomenclature, that is wherever the OH group is basically attached, that should get the least number. So I can't find any other substituent, so therefore obviously this carbon will be the carbon number 1, and on this carbon only the ethyl group will be attached to it. So that's the reason that what I can do is I will attach the ethyl group, and the ethyl group is nothing but C2H. So this was one of the easiest one that I think I have mentioned here. So now let's do the next one. So the next one is 2,4 dimethyl hexane 1,3,5 triol. So for that, suppose the name is big, but the method is very much easy. For example, we have to always consider the parent gene, and in this case the parent name is what we have got it as hexane triol. That means a straight chain consists of 6 carbon atoms. So that is what I am going to mention here. That is carbon number 1, carbon number 2, carbon number 3, 4, 5 and 6. So let me number it also. That is, if I number it as 1, 2, 3, 4, 5 and 6. So this is the main thing that I have did. And the next thing is what I could find is on the position number 2 as well as on the position number 4, I could find methyl groups, and therefore the whole chain consists of that is 2 methyl groups as a substituent. So therefore what I can do is I will go for carbon number 2, and I will mention here as a methyl group that is CH3. Not only carbon number 2 but also in carbon number 4. So here basically I am attaching the methyl group that is carbon on carbon number 4, that is methyl group, and the work is not done yet. Obviously the main functional group, that is an alcoholic functional group, that is what I could say is hydroxyl group, is also remaining, and those are present at carbon number 1, 3 and 5. So therefore this is carbon number 1, so I could write it as OH here. On carbon number 3 I could write OH here, and I could write OH on the carbon number 5. So this is what I have did. But still the work is not been done yet. The reason behind that is I have not fulfilled the valence with carbon atom. So let me fill that also. That is, now this it will be CH3, this will be CH, again this will be CH, this will be CH over here, and here also it will be CH, and here it will be CH2. This is the molecule for, or this is the structure what I mentioned for, that is 2,4 dimethyl hexane 1,3,5 triol. A bit easier. So now let's do the next one. So the next we have is 1-phenyl propane 2-ol. So as I have said earlier, that is we have to look the parent name, and the parent name is basically propanol. So therefore I could write it as, and propanol consists of 3 carbon atoms. So therefore this is carbon number 1, 2 and 3. On position number 2, I could find the presence of OH group. That's the reason that the name is propane 2-ol. But let me give the numbering to this one also. So this is carbon number 1, 2, 3. And on position number 2, I could find the OH group. So that's the reason I am mentioning over here as OH. But on carbon number 1, I could find a phenyl group. So that's the reason that this is carbon number 1, and that is how basically I could write the phenyl group over here. So now most of the work is done, and still this is not complete. Yes, we have not fulfilled the valence of carbon atom by hydrogen atoms. So this will be CH3. Here it will be, I would write it as CH2, and here it will be CH. So this is the structure of, that is 1-phenyl propane 2-ol. And now let's move to the next one. So the next one that we have got is 2-methyl 4-phenyl but 3-ene-2-ol. Okay, this is a quite bigger one. So let us understand that is how we can write it. But the main thing is we have to focus on the parent chain or the parent name for this one. So the suffix, that is what we have got over here, is like but 3-ene-2-ol. So but, it means obviously it will consist of 4 carbon atoms, and that's the reason that I mentioned here 4 carbon atoms, that is I could consider as methane, ethane, propane, and butane. So now just number it. So I will number it from here as carbon number 1, carbon number 2, carbon number 3, and this is carbon number 4. And let's understand that about the substituents. Talking about substituents, I have got that is 2-methyl. So 2-methyl, that means on the position number 2, I could get a methyl group. So that's the reason I will write it a methyl group, that is CH3. On position number 4, I will get phenyl group, and that's the reason that on position number 4, I'm mentioning here a phenyl group, which is nothing but this one. And what else I could find? I could find that is there is a functional group or a carbon-carbon double bond at carbon number 3, or between carbon number 3 and carbon number 4. So that is the reason I'm mentioning here as between carbon number 3 and carbon number 4, there is a presence of double bond over here. And yes, on the position number 2, I have got OL. That means on position number 2, I have OH group that I should attach. So here we say I should attach the OH or the hydroxyl group over here. Most of the thing is done. Let us fulfill the valency. So now this will be CH3. Here there is no thing to add on because it has been fulfilled. Talking about this carbon atom, only one valence is be left, so that would be fulfilled by only one hydrogen atom that would be attached over here. And talking about this also, here only one hydrogen atom would be attached over here. So therefore, this is the structure for 2-methyl 4-phenyl but 3 in 2-ol. And now let's move to the last one. So friends, we have the last one, and the last one has that is cyclohexane 1,4 diol. So now let me give you that is how can we write the structure of it. So first of all, let me tell you that it is not an hexane. It is a cyclohexane. So that's the reason that we have to mention the cyclohexane. The cyclohexane has a structure of this one resembling like a benzene. But on the carbon number 1 and carbon number 4, there is a presence of OH group. So to which one I could get the carbon number? I could get the carbon number 1 to this one. So now at any way that's clockwise or anti-clockwise, I could give the numbering. So let me give it numbering from here. That is 1, 2, 3, and 4, 5, 6. But on position number 1 and on position number 4, there is a presence of OH group. So therefore here it is OH. And on position number 4 also there is OH. So this is the structure of cyclohexane 1,4 diol. So that's it. So friends, this is how we can give the structure to a particular name that is representing the IUPAC name for an alcohol. So that's it. So thank you friends for watching this video. I hope you have got an idea that how can we draw the structure of the alcohols. So now I hope I will see you next time. So till then, don't forget to subscribe to the channel. Thank you so much.